Good morning, everybody. As Ashish said, sorry I couldn't make it yesterday, but good to be here. Year 3 of SONiC India conference. It's so exciting to see room packed here and so much, ecosystem and enthusiasm building here around SONiC. My name is Saurabh Kapoor. I lead product management strategy for AI compute and networking solutions at DELL. I also represent DELL on the governing board for SONiC at Linux Foundation. It's so fascinating to see the world of SONiC evolve and expand quickly, and thanks to AI, networking is cool again. We'll talk about a lot of those interesting evolutions and developments as we go through the session today. But before we start, right, when we talk about AI, the first thing that comes to the mind is those gleaming architectures, those GPUs and computes, the racks, right? But what we don't realize sometimes is the information highway, the networking, right? Meta, talked about this a little bit, at OCP. 57% of time a packet spends, AI infrastructure is networking, right? So you could have the fastest, compute, but if you don't have networking done right, you're not going to get the peak performance. So we're going to talk about that a little bit in the session and what's happening in the world of networking. And then, the other way one of the metaphors I've used is, AI is a race, right? You have, GPUs, which are the runners. But most important is the baton pass, right? In a relay race, that baton pass is the most important thing. And that's where networking and all the capabilities, the AI optimizations in networking that come into play. So let's jump into that and talk about it. But before I get into the details, I'll share a little bit, a proud moment here at Dell. Forrester recognized us as one of the leaders in the AI category. They went about looking at the top 10, 12 infrastructure providers, and they rated us in the leadership category for a few things. One is, our ability to, create partnerships and solutions, right? AI is a lot about, compute, storage, and networking coming together to deliver an end state that we can deliver to our customers, our users, to promise that, irrespective of what workloads they're going to put in, training, inferencing, fine-tuning, is going to deliver the performance they expect, right? So that was about, bringing the right solutions and the partnerships together. The second was supply chain, right? In the world where AI, the innovation is happening so quickly, we're talking about GPUs with, GB300, MI355s. It's evolving so quickly, and so is the networking associated with those, right? So first to market, time to market, and delivering the technologies in time is as important as the technology itself, right? So our ability to partner and build the right supply chain ecosystem was also important. And third is, the promise, right? They're bringing that choice and flexibility and open standards architecture. We've been, working on SONiC for the last 8 years, championing this on a portfolio from 1 gig to 800 gig, and now 1.6 terabyte very soon, is something that is very encouraging. So creating that open standards architecture with SONiC, creating references and validated architectures for that was something that is differentiated. So they recognized all of these things and acknowledged with that rating. AI factory. AI is not built in labs anymore. It's built in factories, just like we saw the industrial revolution happen, where technologies were built and the innovation was happening. It's all coming together. It's all coming together in the world of AI. Starting from the left to right here, data is the most important thing. It's you're looking at billions, trillions, of data and parameters coming out from these large language models. Text and graphics, videos, whatnot, right? Data is evolving quickly. So years of expertise in the storage side, structured, unstructured data, bringing all of that together and creating a highly optimized storage ecosystem to provide to these large infrastructures, right? When I talk about infrastructure, it's compute, storage, and networking, right? There's so much churn in that space. So bringing the right technologies in, bringing the right optimized architectures together, ensuring that the end state of performance is delivered as expected is what is important, right? And then we talk about open ecosystem, right? Because that is where the real innovation lies, right? No single vendor on the planet can deliver an end state of AI. So you have to have the right partnerships in place to bring that ecosystem together, to bring the right solutions together. We announced a lot of frameworks with Cohere, Mistral.ai, and others to bring that solution approach together. And finally, services, right? From day 0 to day 2. We talk a lot about bringing infrastructures, right? Next gen speeds and feeds. But we don't realize that, hey, what happens when it goes into production, right? You need to ensure that those users are, have a 1-800 support to enable that end state of services and capabilities. So and then this is especially important when we start to look at the enterprise market, right? AI enterprise market, where AI talent and skill set is limited. So bringing the right expertise, highly optimized architectures, reference architectures to ensure that it's a plug and play approach and easier for them to deploy. Finally, use cases when it all comes together, right? Training, inferencing, fine tuning. There's a lot of conversation about, hey, building the AI fabrics. But I see it differently. It's building, very special use cases and architectures for training, inferencing, and fine tuning because the needs are very different. And this is where SONiC comes in, right? Born in the hyperscaler world, Microsoft, and now, expanded across the board. It natively brings the capabilities around programmability, adaptability, irrespective of what workloads you want to run on it. You can, customize the solution infrastructure based on the capabilities that you need. And later in the session, we'll talk about, capabilities around load balancing. How do we manage those congestions in the network? How do we make these infrastructures more intelligent? Is what is possible with SONiC. So that's AI Factory. Now looking at the workloads, the world has changed so much in the last 1 year around AI workloads, from the largest GPU factories, the AI farms that we talk about, the AI factories. They're building super large large language models that are now leveraged into the fine tuning and inferencing side of the world. Distributed inferencing is the next big thing. But between training and inferencing, the networking characteristics are so different. With AI factories, the GPU farms and training workloads, you're seeing super large clusters, right? Thousands of GPUs coming together, petabytes of data flowing to these, environments. But when you talk about distributed inferencing, maybe it's a single rack out there in a store, in a bank, doing distributed inferencing. A while back, I was talking to one of the largest retailers out in North America, and they said, well, Saurabh, our stores will not be stores anymore. They'll be, mini data centers with the amount of, compute we are going to bring into these stores, or so-called, mini data centers. A security camera is not going to do security anymore. It's going to look at, the avocado heap. It's going to run analytics around it, predictive analytics, send alerts to the store manager to act on it and make decisions on it. It'll improve, their efficiency, their workforce productivity, and the management overall. So the distributed inferencing workload is going to be very different. We talk about a lot of quick action, latency, jitter becoming important and critical here. Where for the training workloads, we talk about ensuring that it's the elephant flows, the bursty traffic, so you have links and congestion managed efficiently in those environments. So there's a little bit of change I see from what we were looking at AI fabrics earlier to now, highly customized and unique environments and infrastructure for each of those workloads. Here's a breakdown of the three connectivity tissues in the AI fabric, a breakdown of XE9680, a compute platform, 8 GPUs in a box there. Now we're looking at one servers or a couple of servers in rack, but as you look at the super large clusters being built, 72 GPUs packed in a rack now. Right? The networking needs are going massive across these environments. So you have the scale out architectures, InfiniBand, Ethernet, catching up quickly with all the optimizations that have, made its way into these infrastructures. Scale out offers, choice between InfiniBand and Ethernet. You have the front end, the storage access connectivity that's been Ethernet's, game all these years, and then the management fabric. And then now we're looking at beyond the racks and scale across and other, key technologies and use cases have started to emerge, and how Ethernet is going to pave its way into these environments. So let's double click into AI networking characteristics, right? And this is where we start to look at the speeds and feeds, right? Obviously for these workloads, throughput is important, the elephant flows are important, the bursty traffics, the pipelines, have to be, super large to allow that data, mobility across those racks. And if you look at, these environments, these are, building up quickly. You have 1.6 terabyte out there to allow that data mobility across the board. Tail latency, job completion timeline is most important, right? The last man, the packet has to, traverse to ensure that the job completes. Then you start to look at, different routing techniques, to enable, easier, management of the fabrics, allow, that data mobility across the board, without hogging the network, the uplinks in the fabric, and making sure that, the mobility, the dynamic load balancing, the global load balancing, and other technologies play a key role here. So when we start to double click into the feature capabilities, right, we look at, priority flow control. This is where you start, to look at avoiding those packet drops or ensuring that, blockages in the network anymore. Then you start to look at explicit congestion notification capabilities where, it sends the packet to a source and when a buffer, is achieved there. Enhancements here include around latency and path markings, with ECN plus DCQC and, technologies coming together. Load balancing techniques, we're looking at dynamic load balancing, global load balancing capabilities in the fabric. We're looking at, the load on every link, making intelligent decisions across the fabric. And it's more like the nervous system where, the nervous system in a human body, you're connecting all those organs to make decisions, but you're sensing, adapting, and making intelligent decisions in real time to ensure that, it's highly optimized and delivering to the capabilities that is expected. And finally, hashing, right, to address those low entropy use cases and managing those fabrics. So those are the key capabilities that we have seen out there, users deploying it, simplifying it, now rolling into SONiC, environments, championing in SONiC overall. The big debate, right? InfiniBand versus Ethernet. So we started working with some of our partners to establish, hey, is the Ethernet ready? And here's a proof point, right? What you're looking at the chart here is, a comparison between, 400 gig capacity, so comparison between InfiniBand technology versus, Spectrum-X versus, silicon with Broadcom running SONiC. So when you look at traditional legacy Ethernet, which is no AI optimized capabilities, so no Rocky, no load balancing, congestion management capabilities, out of 400 gig, you're going to get 280 gig, right? So not optimum, not ideal, but as we look at InfiniBand, it's 386 out of 400, great. InfiniBand as technology has been out there for years, championing these HPC clusters, AI clusters, and delivering, what it, is expected. But with all the innovation catching up into the AI side, on the Ethernet, side, we're seeing that Ethernet performing similar, or what is expected from AI. So with Spectrum-X, it's about 386, and then with SONiC on Broadcom, we see 385. So it's delivering same capabilities, same performance as is on InfiniBand. So when that debate happens, hey, Mr. Customer, when you're looking at technology choices, you have now options to build the infrastructure that best meets your requirement. With Ethernet, what you see is a big ecosystem, right? All of us are representing different environments. That is a big differentiator with Ethernet, where you have the ability to choose a platform of your preference, pricing, TCO advantages. The way you manage your fabric, the way you orchestrate your fabric is differentiated. So hardware has become highly optimized, highly commoditized. A lot of choices there, and it continues to innovate, evolve with new vendors and partners coming in. The speeds have doubled. I used to say every 24 months, but it's now every 12 to 18 months the speeds double. We're talking about 1.6 terabyte, and the next evolution is out there. So by end of next year, we'll have the next rate and speeds come out. So the mantra is choice and technology between InfiniBand and AI optimized Ethernet is out there. The customers pick and choose the technology that best meets their infrastructure requirements. When we talk about AI optimized Ethernet, I showed a few networking capabilities and protocols that you need to deliver that. Then we looked at how do we compare those infrastructure blocks across the board, InfiniBand and Ethernet choices. But this is where the fine tuning in the fabric comes into play, right? When you do the ECN, the PFC settings, adjusting thresholds and the buffer settings, when you're looking at the load balancing capabilities and tuning those flow idle timeouts, ensuring that the traffic distribution is done appropriately, ECMP to address the Jenkins hashing, and then you do some optimization of the server side with the BIOS settings, graph, kernel, PCIe settings, enabling those capabilities. But all of those now are getting baked into orchestration, right? Orchestration is becoming that intelligent tool that allows you to simplify and manage these environments, simpler and easier. And that's where a lot of play in the AI enterprise market comes into thing, right? So we're seeing that all these optimizations packaged together in orchestration solutions allow you to simplify and manage these environments efficiently. Based on the scale and sizes, right? Different options to connect your fabric. You have 8 GPU rail architectures, a single network rail, single switch can bring that connectivity across 16 compute platforms. when you start to get into 2 GPU rails, 1 network rail, 6 switches, 32 GPUs coming together, so different, network designs that we've seen, and this is, common across the AI enterprise market. But as we get into super large, AI deployments that we've done across with different solutions, we see that scales and sizes, dramatically, grow. Right? This is a representation of a 64, compute cluster, and then, a rack layout view with one of our, largest deployments out there. Another representation of 8,000 GPU clusters, 192 switches, 128 leaves, and then 64 spines, coming together. Now you're looking at 512K thousand GPU clusters. And these speeds and feeds continue to grow. The AI clusters are continuing to expand, and this is, the art of the possible, right? So different network designs, different capabilities. Ethernet today can achieve all the way up to 512K GPUs, right? So that's the, the new world we are seeing, 20,480 switches, right? And and the sky's the limit. All right, so we spoke about infrastructures, Ethernet, speeds and feeds, the optimizations that come in the SONiC, the network operating system capabilities. But there's so much happening on the optics space as well, right? Linear pluggable optics. That's a new big thing, and we're seeing a lot of innovation happen there. With linear pluggable optics, the big thing is you're taking the DSP out of the optics and using the DSP on the host. And that helps you simplify a lot of things, right? One, it brings down your power consumption. It brings your power consumption all the way like 50% lower. It improves the latency in the fabric by 98%, right? Using, the DSP on the host to do a lot of things that would happen on the optics side. And we recently got all of those qualified with SONiC, all the improvements in the optimizations have to happen in the LPOs supported on SONiC, and now we're the first ones to enable an end-to-end connectivity across from servers to the switch with linear pluggable optics. And the big mantra is practice what you preach. DELL IT has deployed SONiC across the board. All of our, we have 23 global data centers. We have, several thousand switches running SONiC. Our path to, grow is 100% SONiC deployments across the board. All of our branch offices, our data centers are going to be SONiC-powered. And then enterprise applications, Teams and Zoom and all these applications, as well as our AI infrastructure. We are big on AI in as we are exposing AI out to our customers. So we're building a lot of applications, Codium infrastructures for engineering functions. We brought in AI for our supply chain. We brought in AI into our services organization to be better at what we do across the board. And then all of these are running on SONiC infrastructures, right? So we're building case studies around it, reference architectures, and we're going to be soon rolling it out. We've already done case study and a video testimonial out, how DELL IT has deployed SONiC across these variety of workloads. We're on the path to get to 10,000 switches across SONiC and then 40,000 switches in the next couple of years. So big on SONiC, and then LPO with all these enhancements, innovations coming in. The optics side, we're enabling those as well. Smart Fabric Manager for SONiC. So this is a technology that we rolled out last year. It's a fabric management solution where we help simplify, fabric's rollout with SONiC. It's only supported with SONiC. Big believer of simplifying, the fabric management capabilities, be it the core data centers or AI fabric capabilities. We're expanding the product capabilities and use cases supported with this management solution. We see a big play in the AI enterprise market. Blueprint-based, specific to different GPU architectures, different rail optimized, topologies. We've got a lot of our storage solutions, compute solutions orchestrated and put in a blueprint. So that's one-click, plug-and-play approach for our users. And then, adding power, thermal observability capabilities to deliver a rack solution, an integrated rack solution, because a lot of times these AI customers are looking at multiple management solutions. They have a management tool for compute, they have a management solution for networking. But when it comes to AI infrastructure, you're looking at a lot of, end-to-end. You're looking at GPU to NIC to ASIC telemetry flows. You're making sure that if the packet drop happens or link flap happens, you have the ability to look and decipher in the fabric what happened and why it happened, right? So integrating those management tools together to create, that end-to-end view. So that's on Smart Fabric Manager, actively growing the capabilities and use cases. But here we go with, the next big thing is, build versus buy versus partner. So while we're building our technologies together, we're also partnering with the right organizations. So BE Networks, with a cluster of their tools between Verity, Satori, SenseAI, we're bringing an end-to-end AI infrastructure, solution management capabilities together. Why? Because that closed loop monitoring where, a technology that monitors what's happening and is able to make actions into the fabric to create intelligent fabrics is super interesting, right? So this is where we're seeing a lot of activity, a lot of interest around, these technologies coming into play. So we partnered with them, we've expanded those capabilities, supported with SONiC across the board, multiple deployments with the customers. We have 300 plus customers deployed across the board with SONiC and a big portion with our partner solutions as well. So big believer of open standards, choice of technology to bring that in, right? So when we look at AI infrastructures, as I was talking about, limited skill set, there's a lot we're doing around SONiC in terms of simplifying SONiC deployment, right? One thing we constantly hear from the users and the customers is, hey, where do I go for SONiC documentation, training, certifications, and things like that. We have created SONiC trainings. We've created SONiC, deployment reference architectures, POC guidebooks, use case guidebooks, hands-on labs, GNS3 virtual images, simplifying user adoption across the board. And then, addressing those capabilities throughout the life cycle, right? From infrastructure assessment to design and architecture discussions, enabling those different, use cases from core to AI fabrics, giving users the ability to, to see what they're going to deploy, from GPU server rack builds to switch and cable physical installs, cluster builds, acceptance and validation, and finally managed services as well. So full suite of services capabilities to simplify core and AI deployments, championed by SONiC across the board, certifications for end users to go through deployment trainings, be it virtuals or in-person. Big believer in SONiC across our infrastructures. We continue to expand our partnerships because that's a way ecosystem is important, and creating that open standards is important, and SONiC allows us the platform to create, innovate, and build. And the goal here is to create end-to-end connectivity tissue, right? We're talking about AI as a race with runners as a GPUs, the baton pass as the networking. And it's important that while you have the best of compute, you have the networking done right, the smoothest baton pass so that you avoid any infrastructure breaks, packet drops, or anything that that surprises you in the fabric. So creating an end-to-end infrastructure, bringing our compute, storage, and networking together in packed reference architectures with the right partner solutions to deliver flexibility and choice of technology when it comes to AI infrastructure, right? As we have partnerships on the compute side with NVIDIA, AMD, and Intel, we have partnerships on the networking side with Broadcom and NVIDIA, supporting InfiniBand and Ethernet as technologies there. And we continue to innovate that, big features, enhancements available with SONiC. We continue to innovate across the board, both on the hardware side, the cables and optics, and as well as on the software side. And the software side includes both network operating system and the orchestration side, both building in-house and doing the right partnerships, key niche players who know what they're doing and delivering the right technologies that are relevant for the markets. Packaging all of that together into validated designs and reference architectures so that it's plug and play for end deployments, and then building a comprehensive suite of services capabilities addressing from day zero all the way to day two. Why? Because that day two is important. When everything goes live, you need to make sure that you have those switches blinking green and enabling that connectivity across the board. So that was my presentation here. Open for any questions. Go ahead.
So we saw the roadmap. We talked about LPO. What about CPO?
Good question. Co-packaged optics is the next big thing. We have those on the roadmap actively. Now there's a big debate between LPOs and CPOs. It's a choice of technology and very different technologies across LPOs and CPOs. With co-packaged optics, you simplify the infrastructure quite a bit. Both our partners, Broadcom and NVIDIA, have solutions that are in play for that market. So as we get to the 1.6 terabyte play with the switching, we're going to look at a lot of those, CPO platforms come into play as well. At that time, it's a choice of, LPO versus CPO and the benefits for each. Any other question?
Over there.
Venkat?
Are you seeing L1 optical, that MEMS topologies? Because AA especially, there is so much talk that happens on topologies. Because I saw somewhere you said, 8 rails, 1 switch, right? So
Yeah. No, we've seen different. CLOS was the big topology that we had in the data center, relevant there. But we see a lot of rail optimized architectures, rail optimized, topologies that are relevant into the space, and especially when it comes to a few, thousand racks, especially in the CSP and the AI training, large language model category, the AI factories. So we see a lot of rail optimized architectures. Lots of innovation happening in the optics space, and we're looking to bring that in terms of what that connectivity looks like. Obviously, CPU is going to play a big role on how those, building blocks of pods and rack layouts looks like. So yes, those architectures evolving, and right now, rail optimized is big prevalence across the user space.
Okay. Do we have? Yeah.
Thanks for the wonderful talk. I'm Raj from Nextop. I wanted to know about your thoughts regarding the industry adoption about the Ultra Ethernet Consortium spec.
Very good question. Ultra Ethernet Consortium is actively pushing, Ethernet into those use cases. InfiniBand has been championing the HPC use cases all these years. With Ethernet, we see, those latency catching up to 600 nanoseconds, but when you get into low latency use cases, especially with distributed inferencing coming to play, you're looking at 200 nanoseconds of connectivity. And Ultra Ethernet Consortium, is doing a fantastic job building those specs and what those next gen technologies look like. As we start to see a lot of, Tomahawk Ultra and all those technologies come into play, we start to hit a lot of those UEC specs addressing those, scale up use cases as well as scale across architectures and distributed inferencing use cases. So yes, UEC will be a big part of I think broader ODM use cases. We are actively looking from a DELL perspective as well. We're part of the consortium as well, and we'll bring in all those innovations, both on the hardware side as well as on SONiC. So we have to make sure that the full stack, both across hardware and software, supports it. So we have some of those link layer, optimizations making its way into SONiC for next year.
What about scale up? Are you guys SU, PCIe, like UA Link? What are your thoughts? Yesterday was UA Link, but
Yeah.
I heard Ram talk about it like a few weeks ago at OCP, and
Yes.
it was hilarious.
Yeah, no, absolutely. Scale up is changing quite a bit. Next gen silicon technologies are going to be a big influencer there. UAL over Ethernet is something that we're looking at. And then I think with both, Tomahawk 6, Tomahawk Ultra being a big, focus area for next year, we're looking at positioning there. Now, there are a few things that have to come into play. What cert is connectivity, what GPUs are going to connect, like we're working with AMD quite a bit in that space, bringing Ethernet connectivity in that, ecosystem. So what is that SerDes connectivity with Tomahawk 6? What latency parameters look like? How do we bring that reference architecture together? What performance, are we seeing with those solutions? And then again, with Tomahawk Ultra, 200 gig SerDes and other technologies coming into play there. I do see Ethernet making its way into scale up, but mostly around second half next year, we'll start to see some of those technologies rolling into some of the CSP environments, and there and start to see those making its way into AI enterprise. But Ethernet is slowly making its way into the scale up fabrics, and UL over Ethernet is going to be a big focus area going forward.
So can you detail more about in the software, what are the innovations that are happening to achieve this?
Yeah. I mean, yes, so we are following the UEC specs, 1.0 and 1.5
Right.
talking about. The innovations are going to be both in the silicon side as well as the network operating system. The link layer, retries and some of the retransmissions, etc., is going to be simplified quite a bit in the software stack next year. So we're looking at it, what the specs are telling. Obviously, there has to be a full development cycle that goes into building the software capabilities and then proving what it's going to deliver. So a lot of active development in that space is what I'll share at this point, and then we'll start to see some performance results come in the second half next year.
Okay.
Okay. Do we have any more questions? If not, thanks a lot, Saurabh,
Right.
for
Thank you,
opening
Ashish.
the second day.
Thank you.